At this point, I'm going to skip over a bunch of details. For example, which features are we going to use to make the code words? What size should there be? When you do a vector quantization, sometimes it'll tell you how many code words it thinks it needs, or sometimes you give it a number. We're not going to talk about that. And we're not even going to talk about the clustering or the vector quantization algorithm. Instead, we're going to focus on how would you use that in a way that relates to the SVMs that we just talked about in order to do recognition. So what we do is we're going to continue with our analogy to documents. So here I have two different documents. And if you take a look at the document on the left, you'll see a whole bunch of words in here, right? Sensory, brain, visual perception, etc. Nerve, image, Hubel, Wiesel. Hubel and Wiesel, by the way, are people who won Nobel Prize for understanding what goes on in the visual cortex of the cat. All right. And here's another document: China, trade, surplus, exports, domestic, foreign, increased, trade, value. Notice that what's in the magnifying glasses are not ordered. It's just the words that happen to be in that document. It's like you stuck all the words in a bag, and that's where we get this notion of bag of words. Okay? And the goal of what we're going to talk about now is to go from object recognition and map that onto a bag of words. And in the document world, you know, one way of doing it is I have my bag of words and I say, what is the distribution of words in this document? And if I wanted to do document retrieval, I want to find other similar documents. A simple thing you might do is find other documents that have sort of the same histogram distribution of words, and that's likely to be a matching document. Things are much more sophisticated now in terms of how that works, but the basic idea is that I've got these code words that represent, or these words that represent something about the semantics, and so a similarity in distribution tells me that maybe there's a good chance that it's a similar type of document. So we want to do this in computer vision. So that's notionally represented here. So I've got a bunch of different objects, and I compute my features over all of these different objects, and I come up with what's shown down here. And I think this slide originally is from Fei-Fei Li, I'm not sure. And all of these are all of my code words for all of my different objects, right? So I take all my objects, and it's kind of like if you take all the documents in a library in the United States, and if they're all in English, you took all of those documents together, all of the words would be the set of the words that span all of those documents, right? And in fact, there are many more documents than there are words. And in fact, if you think of important words, words that actually have a lot of meaning, there's way more documents than words. So given a collection of words, visual words, for every document, I can say how many of each word is in each document. And that's what these histograms are meant to represent, right? So, you know, the bicycle has got these little bicycle pieces in it, all right? And something that might kind of look like this, I don't know, maybe, you know, this brown part down here looks a little bit like that brown part down there. But the idea is that there's many more of the bicycle elements than there are of the violin elements. This is referred to as a bag of visual words for obvious reasons. And the idea is that you're describing the entire image just by the histogram or the collection of those words. And you want to do access the same way they did in the documents world.